66 million years ago, the history of life on Earth hung by a thread. A rock the size of a mountain, a 10-kilometer sphere of carbon and iron, was hurtling through the cold silence of space at 20 kilometers per second. Its trajectory had been shaped by the subtle gravitational nudges of Jupiter, by the passing of comets, by the slow, chaotic wobble of its own spin over eons. In the history written in stone, that rock struck the Yucatan Peninsula with the force of 100 million nuclear weapons, ending the Mesozoic era in a flash of sulfur and fire. But tonight, we explore the timeline where the laws of orbital mechanics played out just a fraction of a second differently. The rock screams through the upper atmosphere, a white-hot scar across the sky visible for 1,000 miles, but it does not strike the land. It misses the shallow seas of the Yucatan. Instead, it splashes down into the deep waters of the Pacific Ocean, 2,000 kilometers from the nearest coastline. There are tsunamis, certainly. Massive walls of water devastate the coasts of Asia and the Americas. Millions of creatures die in the immediate aftermath. Coastal ecosystems are scrubbed clean, but the sulfur does not choke the stratosphere. The sun does not vanish for a year. The global winter never comes. The dinosaurs of the late Cretaceous, the most successful dynasty of land animals the planet has ever known, wake up the next morning to a world that is shaken but alive. And they continue doing exactly what they had been doing for the previous 165 million years, dominating every terrestrial ecosystem on Earth. To understand the world that follows, we must first dismantle a persistent myth. We are often taught that the dinosaurs were already a dying breed, lumbering, cold-blooded failures, waiting for the energetic, warm-blooded mammals to take their rightful place. This is a lie. The late Cretaceous was not a period of decline. It was a golden age of biological engineering. The world of 66 million years ago was warmer, wetter, and more abundant than our own, with sea levels 170 meters higher than today. North America was split in two by the Western Interior Seaway, a warm, shallow ocean teeming with marine reptiles. There were no ice caps. Forests stretched from pole to pole. And in this greenhouse world, the dinosaurs were not merely surviving. They were thriving with a physiological superiority that mammals could not match. Consider the Tyrannosaurus rex. Strip away the movie monster image and look at the animal as it truly was. 12 meters long, 9 tons of muscle, built not for endurance running, but for explosive, terrifying acceleration. Its skull was an engineering marvel, capable of crushing bone, but its true power lay in its senses. It possessed binocular vision, superior to that of a modern hawk, and an olfactory bulb large enough to smell a carcass, or a living meal, from miles away. It breathed using a unidirectional airflow system, similar to modern birds, extracting oxygen far more efficiently than the bellows-like lungs of any mammal. While mammals gasped for air, dinosaurs oxygenated their blood with a constant, rich stream, fueling bodies that grew faster and larger than anything else on land. The mammals were there, of course. They had been there for 150 million years, while living in the literal and metaphorical shadows of the giants. But they were not held back simply because the dinosaurs were big. They were held back because the dinosaurs were better at being big. Mammals were restricted to the nocturnal, the burrowing, and the arboreal niches. They were the rats, the shrews, the badgers of the Mesozoic. In this alternative timeline, the asteroid's near miss does not liberate them. Instead, it condemns them to another 66 million years of the same ecological suppression. The niches for large herbivores and apex predators remain firmly occupied by animals that lay eggs, grow rapidly, and breathe with superior efficiency. 10 million years pass. The calendar turns to 56 million years ago. In our timeline, this is the Paleocene, a time of recovery. In this timeline, it is simply the continuation of the Cretaceous. But the world is changing. The flowering plants, the angiosperms, are waging a quiet war against the conifers and ferns, spreading across the globe and developing a revolutionary new strategy: fruit. They bribe animals with sugar to carry their seeds. In the history we know, this explosion of fruit drove the evolution of primates. But here, The trees are claimed by the dinosaurs. Small, feathered theropods, the ancestors of raptors and troodontids, adapt to the canopy. They already possess grasping hands and stereoscopic vision. Now they evolve to be lighter, more dexterous. Picture a creature the size of a monkey, but covered in iridescent feathers, leaping from branch to branch with a hooked beak designed to tear into tough tropical fruits. These are not birds, but arboreal dinosaurs, one filling the ecological role that monkeys would otherwise occupy. They are intelligent, social, and utterly dominant in the high branches. Then around 55 million years ago, the planet faces a crisis that has nothing to do with asteroids. A massive release of carbon, likely from volcanic activity in the North Atlantic, or destabilized methane hydrates, triggers the Paleocene-Eocene thermal maximum. Global temperatures spike by up to 8 degrees Celsius. The poles become tropical. Palm trees grow in Alaska. Crocodiles bask on the shores of the Arctic Ocean. It is a hothouse world, hotter than anything in human history. For mammals, this heat is a metabolic nightmare. Mammals must burn energy to maintain a constant body temperature. When the ambient heat rises too high, they cannot shed that heat and they die. But large dinosaurs are gigantic therms. Their sheer mass stabilizes their body temperature. They absorb heat during the day and retain it at night, maintaining a stable internal environment without the high metabolic cost of mammalian endothermy. As the world burns, the dinosaurs do not wither. They expand. The tropical dead zones around the equator force massive migrations toward the poles. Antarctica, green and lush, becomes a sanctuary for the titans. Herds of sauropods, the long-necked giants that had been specialists in the Cretaceous, find new life in the dense polar forests. Without the extinction event to wipe them out, the marine reptiles, the mosasaurs and plesiosaurs, also adapt. In our history, whales evolved to fill the void left by these sea monsters. In this history, the void never opens. The oceans of the Eocene remain the domain of the reptiles. Mosasaurs, streamlined and terrifying, grow to lengths of 20 meters, hunting in the warm, shallow seas that cover much of the continents. They are the orcas of this timeline, but scaled up to nightmare proportions. Pterosaurs, too, find the Eocene hothouse to be a paradise. In our world, they vanished with the dinosaurs, leaving the skies to the birds. Here they partition the heavens. Birds dominate the lower, cluttered environments of the forests, but the open skies belong to the Azhdarchids. Imagine the Quetzalcoatlus, a flying reptile with the wingspan of a fighter jet, stalking the open floodplains on four stilt-like legs, snapping up small dinosaurs and mammals with a beak as long as a spear. They are the lords of the air, riding the thermal currents of a fevered planet. By 50 million years ago, the Earth has settled into a warm, stable equilibrium. The dinosaurs have not just survived, they have integrated into the changing botanical landscape. They have weathered the thermal shock of the global warming event. They have kept the mammals underfoot, restricting them to the dark and the dirt. To an observer, it would seem that this reign could last forever. The planet is a machine built for reptiles, fueled by heat and high carbon dioxide. But the Earth is restless. Deep beneath the surface, tectonic plates are grinding together. India is slamming into Asia, raising the Himalayas. Antarctica is drifting south, slowly tearing away from South America. The currents that keep the world warm are about to be broken. The long summer of the Mesozoic is ending, and a new, colder, sharper world is coming. A world of ice and grass that will test the dinosaurs in ways the asteroid never did. Around 34 million years ago, the planetary thermostat began to turn down. The cause was tectonic, a slow-motion collision of continents that altered the flow of the world's oceans. Antarctica, which had been a green sanctuary for the dinosaurs during the heat of the Eocene, finally separated from South America. A new current, the Antarctic Circumpolar Current, began to churn around the southern pole, isolating the continent and locking it in a deep freeze. For the first time in hundreds of millions of years, ice sheets began to consume the land. The global cooling rippled outward, drying the air and disrupting the rainfall patterns that had sustained the endless forests of the Mesozoic. The great canopy, which had sheltered the dinosaurs for eons, began to fracture. The trees retreated toward the equator and the river valleys, leaving behind vast sun-drenched voids. Nature abhors a vacuum, and into these open spaces rushed a humble, low-growing family of plants that would change the face of the earth more thoroughly than any asteroid. The grasses. Grass does not seem like a revolutionary organism. It is easily overlooked, trampled underfoot. But starting in the Miocene, around 23 million years ago, grass began a conquest that would reshape the biosphere. Unlike trees or shrubs, grass grows from its base, not its tip. It can be grazed down to the dirt, burned by wildfire, or trampled by herds, and it simply grows back. It is resilient, aggressive, and defended by microscopic weapons. Grass leaves are packed with phytoliths, tiny particles of silica, essentially glass, that wear down the teeth of any animal foolish enough to eat them. In our timeline, the spread of grasslands triggered an evolutionary arms race among mammals. Horses grew larger and developed high-crowned teeth to grind the abrasive silica. Predators became faster and more social to hunt in the open. In this alternative history, the challenge is thrown not to horses and wolves, but to the dinosaurs. And the dinosaurs answer. Consider the ceratopsians, the horned dinosaurs. In the forests of the Cretaceous, they were browsers, using parrot-like beaks to snip tough vegetation. But the open plains of the Miocene demand a different toolset. Natural selection acts with brutal efficiency. The lineages with softer teeth wear them down and starve. The lineages that survive are those that evolve the biological equivalent of industrial machinery. We see the rise of the grazing ceratopsian, a creature the size of a white rhinoceros, but with a head shaped like a shovel. Its beak widens and flattens to crop grass in broad swaths. Its teeth evolve into self-sharpening, ever-growing batteries, capable of pulverizing the silica-laden grass without failing. These animals congregate in herds numbering in the thousands, a river of horns and muscle flowing across the plains, filling the ecological niche that bison and wildebeest occupy in our world. But the shift to open country changes the rules of engagement for predators as well. In a forest, a 6-ton Tyrannosaurus rex can hide. It can ambush prey from behind a screen of redwoods, using a short burst of speed to deliver a bone-crushing bite. On the open steppe, there is nowhere to hide. Prey animals can spot a predator from kilometers away. The classic T-Rex, the ambush specialist of the late Cretaceous, finds itself obsolete. Evolution does not discard the tyrannosaur design, it refines it. The tyrannosaurs of the Miocene grasslands become leaner. The heavy barrel-chested frame stretches out. The legs lengthen relative to the body, optimizing for endurance rather than explosive acceleration. They become pursuit predators, the dinosaur equivalents of the wolf or the painted dog. But a lone predator, no matter how fast, struggles against a herd of thousands. To bring down a 5-ton grazing ceratopsian, the new tyrannosaurs must do something their ancestors rarely needed to do. They must cooperate. We see the emergence of the social tyrant, packs of 6 or 8 individuals communicating with low-frequency infrasound that travels for miles across the plains. They coordinate their movements, flanking the herds, testing for weakness, isolating a victim through strategy rather than brute force. This is a terrifying upgrade to the apex predator, a creature with the killing power of a dinosaur and the tactical intelligence of a wolf pack. And this brings us to the most controversial question in speculative evolution. If the dinosaurs had survived, if they had been forced into these complex social environments, would they have become intelligent? Would they have built civilizations? In 1982, paleontologist Dale Russell proposed the dinosauroid, a thought experiment that imagined a descendant of the small, a brainy Troodon evolving into a humanoid form. The dinosauroid stood upright, had no tail, and possessed a large bulbous head. It looked essentially like a green alien in a sci-fi movie. This image captured the public imagination, but it reflects a deep human bias, the assumption that intelligence inevitably leads to a human shape. This is almost certainly wrong. Crows and parrots today possess intelligence that rivals primates. They solve puzzles, use tools, and recognize themselves in mirrors. Yet they look nothing like humans. They achieved high cognition while remaining fundamentally avian. In our alternative timeline, The intelligent dinosaur does not become a man in a lizard suit. It remains a dinosaur. The Troodon lineage, already possessing the largest brain-to-body ratio of the Cretaceous, which faces the cognitive crucible of the grasslands. They are small, vulnerable, and hungry. To survive in a world of giants, they must outthink them. Picture the result. 20 million years post-divergence. It is a creature about 2 meters long, covered in a coat of mottled gray and brown feathers that blend perfectly with the dry grass. It retains its tail for balance and its sharp, grasping claws. But its eyes are bright with a dangerous spark. These creatures live in tight-knit clans, passing knowledge from generation to generation. They use tools, rocks to crack open marrow bones left by larger predators, sticks to probe for insects or small mammals. They have a complex language of calls and gestures. They may even use fire, not creating it, but carrying embers from lightning strikes to flush prey out of the brush. And they are intelligent, undeniably. But are they technological? Do they build cities? Likely not. The drive to build industrial civilization is a specific, strange quirk of the human primate, born of a unique set of pressures and hands adapted for fine manipulation. The intelligent dinosaurs are masters of their environment, not its conquerors. They do not need to invent the rifle because they have sickle claws. They do not need to invent the internet because their social groups are immediate and physical. They achieve a level of sophistication that allows them to dominate their niche without destroying the biosphere that sustains them. This era, the Miocene, represents the peak of dinosaur diversity. The world is partitioned into a complex mosaic. In the deep forests that still cling to the equator, when the ancient forms persist, sauropods and classic theropods living as they did in the Jurassic. On the vast new grasslands, the innovative grazers and pursuit predators play out a high-speed arms race. In the air, birds and pterosaurs share the sky, with pterosaurs acting as the heavy bombers and birds as the agile fighters. And in the shadows of the night, the mammals continue their quiet, desperate scurry, waiting for a turn that never comes. But the cooling that began in the Oligocene was only the prologue. The Earth is drifting toward a profound, deep freeze. The chaotic climatic fluctuations of the Pliocene are approaching, heralding the coming of the ice ages. The dinosaurs have conquered the heat and they have mastered the plains. Now they face the ultimate test of their adaptability. The glaciers are gathering in the north, and white leviathans that will grind civilizations, had there been any, to dust. The endless summer is truly over. The time of the frozen titans is at hand. 2.5 million years ago, the Earth crossed a threshold from which it has never fully returned. The long cooling that began in the Oligocene reached its logical freezing conclusion. Ice sheets, kilometers thick, descended from the Arctic, burying Scandinavia, Canada, and much of the northern hemisphere under a crushing weight of white silence. The Pleistocene had begun. In our timeline, this was the age of the megafauna, the woolly mammoth, the cave bear, the saber-toothed cat, animals built for the cold, wrapped in fur and fat. In our alternative timeline, the ice still comes, but the giants that rise to meet it are not mammals. They are the frozen titans of the Dinosauria. When the idea of a dinosaur in the snow seems contradictory, a violation of the tropical image we have cultivated for centuries. But nature follows the laws of physics, not the expectations of human cinema. There is a rule in biology known as Bergmann's rule. In colder climates, animals get larger. A massive body holds heat better than a small one. It is a fortress of thermal inertia. And so the ice ages produce monsters. Imagine the Siberian steppe, 20,000 years ago. The wind howls at 40 miles an hour, driving snow horizontally across a landscape of dry grass and scrub. Out of the whiteout emerges a shape the size of a tank. It is a ceratopsian, a distant descendant of Triceratops, but transformed by the cold. It stands 4 meters tall at the shoulder. Its horns are short and thick, purely functional weapons without the ornate display structures of its ancestors. But the most striking feature is its coat. It is covered in a dense, shaggy pelt of protofeathers, a thick wool that traps air against its skin, insulating it as effectively as any muskox. These animals move in herds of thousands, their breath forming vast clouds of steam in the frigid air, their beak-like mouths shearing through the snow to reach the frozen grass beneath. They are followed by the ghosts of the tundra. The tyrannosaurs of the Pleistocene are not the naked, scaly giants of the Cretaceous. They are white, covered in plumage that mimics the snow. They are ambush predators of the deep winter. They have evolved to be patient, to slow their metabolisms during the lean months, waiting for the sick or the old to falter in the drifts. A pack of these white tyrants, moving silently through a blizzard, represents the apex of predatory evolution, a perfect marriage of reptilian killing power and avian insulation. This cycle of ice and thaw continues for 2 million years, pumping the bellows of evolution, driving adaptation at a frantic pace, and then the ice retreats. The Holocene begins. The world warms slightly, settling into the interglacial period that we call the present day. Stand now in the world of today. Not our today, but the today that never was. Look out across the planet. The geography is identical. The continents are where you expect them to be. The mountains rise in the same jagged lines. But the silence is profound. There are no highways cutting through the migration routes. There are no cities glowing on the night side of the planet. Or there is no plastic in the ocean. The atmosphere is pristine, carbon dioxide levels holding steady at pre-industrial baselines. In North America, the Great Plains are a Serengeti of dinosaurs. Herds of grazing hadrosaurs, numbering in the millions, migrate from the Gulf of Mexico to the Canadian border, following the seasonal pulse of the grass. They are stalked by packs of dromaeosaurs, the raptors who have become the ecological equivalent of wolves, endurance hunters that run their prey to exhaustion. In the Amazon, the rainforest is a multi-layered kingdom. Sauropods, smaller than their Jurassic ancestors, but still the largest animals on land, browse the high canopy, their long necks acting as elevators to resources no other animal can reach. The floor of the jungle belongs to the mammals, still small, still hiding, but diverse and successful in the dark. And what of the oceans? In our timeline, mammals returned to the sea to become whales. In this timeline, the mammals found a different door. While the great marine reptiles, the mosasaurs and plesiosaurs, dominated the sunlit surface waters, mammals may have conquered the deep. Imagine a descendant of the otter or the seal, evolved for extreme pressure, hunting in the abyssal dark where the reptiles cannot go. Blind using echolocation, these deep-sea mammals would be the rulers of a midnight world, unseen by the masters of the surface. But the most profound difference in this world is not the presence of dinosaurs, but the absence of us. The specific chain of events that led to human intelligence, the drying of the African Rift Valley, the forced transition to bipedalism, the desperate need for tool use to survive, never happened here. The primates remained in the trees, or they stayed small. The spark of industrial consciousness was never struck. This realization brings with it a strange, melancholic vertigo. If the asteroid had missed, the world would be undeniably beautiful. It would be vibrant, stable, and overflowing with life. But there would be no one to know it. There would be no names for the stars, no one to calculate the age of the earth, no one to weep at the beauty of a sunset or tremble at the horror of a predator's kill. The universe would go on, vast and ancient, without a single witness capable of understanding it. We tend to think of ourselves as the inevitable climax of the story, the point of it all. But the dinosaur timeline suggests we are merely a cosmic accident, a byproduct of a rock falling in the wrong place at the wrong time. We are the orphans of a catastrophe. The dinosaurs did not need consciousness to rule the earth for 165 million years, and they would not have needed it to rule for another 66 million. They simply lived. As night falls on this alternative earth, the sounds are different. The roar of a distant tyrannosaur echoes across a valley that, in our world, might hold a shopping mall or a highway. The wind rustles through grass that has never been cut by a machine. High above, the same moon watches over this savage Eden. It is a world of perfect indifference. It does not care that we are not there. It functions with absolute precision, a biological machine that has run without interruption for 250 million years. And perhaps, in the end, that is the most humbling thought of all. The asteroid was not a tragedy for the Earth. It was merely a change of management. The planet does not miss us in this timeline. The dinosaurs are doing just fine. They are sleeping now, or hunting, or tending to their nests, living out their lives in the long, unbroken chain of history that we broke. So the next time you look up at the night sky, remember how close we came to never existing. Remember the rock that missed in some other turn of the wheel. And remember the ghosts that walk beside us, the titans that should have been here, the rulers who never abdicated, the dynasty that was only stopped by the stars themselves. This is their world. We are just living in the ruins of their empire. What if dinosaurs never went extinct?